Welcome to the CarAudioHelp.com installation video number 3. Today you're going to learn how to create 3 different fiberglass projects. This video will cover fabrication of custom kick panel pods, spare tire well enclosure, and subwoofer enclosures with fiberglass baffles. Let's get started by taking a look at the equipment and materials we'll need to construct these projects. To form a base for our projects, we'll need medium density fiberboard. This will be used to create the mounting surface for our speakers and also to act as braces to temporarily hold the mounting baffles in place. A jigsaw will be necessary for cutting the irregular shaped speaker baffles and for trimming the braces to the proper size. It can also be used for cutting the speaker rings if a router is unavailable. A power drill will be used for any screw holes. A plunge router will be used in combination with a circle jig for creating the speaker rings as well as for rabbiting the edge of the spare tire well baffle. The circle jig being used is the M200 from Jasper Audio. These are available directly from Jasper Audio as well as Parts Express. A fixed base router will be used in a small homemade router table to do any flush trim and roundover work desired. The plans for the router table I'm using are available on the internet. If you'd like the plans, I've provided a link in the included documentation. We'll be using 4 different router bits. The 1/4-inch straight cut bit will be used with the circle jig to create the rings and mounting holes for our drivers. The 3/8 inch roundover bit will be used in the router table to take the hard edge off the outer edge of our flush mounting rings. The rabbiting bit will be used to add a lip around the edge of our spare tire well enclosure baffle. The 1/2-inch flush trim bit will be used to cut away the excess material from our fiberglass baffle mounting rings. A die grinder will be used in conjunction with the 1/2-inch flush trim bit rather than a bulky router. An electric unit such as a Dremel or rotozip could be used with a spiral cutting bit if air tools are not available. A body saw is also recommended for cutting the fiberglass to the needed shape after curing. Again, a Dremel or rotozip with a spiral cutting bit could be used. An angle die grinder will be used for sanding the enclosures. An electric sander could be used instead of an air sander. A rotary sander is recommended over an orbital or jitterbug sander in this case. A staple gun should be used to attach the cloth to the edge of the wood enclosure to ensure a strong bond. An air-powered model is recommended, but an electric or hand stapler will work if 1/2-inch staples are used. A pair of scissors and a razor knife will be needed for cutting and trimming the various polyester cloths that will be used. These do not need to be of a high quality, but they do need to be relatively sharp. A heavy-duty pair of shears needs to be used for cutting the fiberglass cloth and mat. I prefer to use a cheap pair from a dollar store rather than maintain a quality pair of shears. When the cheap ones wear out, I simply purchase another pair. CA glue and hot glue are used to quickly mount the MDF braces to the base and mounting rings from the fiberglass enclosures. CA glue forms a better bond, but hot glue is thicker and can fill in gaps between the brace and the ring. To form the first layer of our wrap shape, we'll need a variety of polyester-based cloths. Polyester is a good choice because it's stretchable and is the same material as our resin. Thinner cloths will be used for more complex shapes, and thicker cloths will be used for enclosure baffles. To temporarily hold the polyester cloth in place, we'll use spray glue. I recommend Super 77 from 3M as a good all-purpose spray adhesive. Fiberglass mat will be used to form the base of our spare tire well enclosure and to duplicate the shape of our factory kick panels. Mats come in various thicknesses or weights and are sold by the yard. The most popular weights are 1.5 ounce and 3 ounce. The thinner the material, the more readily it will take resin and bend around curves. The thicker the material, the stronger it will be when cured. I recommend purchasing some of each. We'll also be using a material called core mat. This acts as a bulking agent and will save time and money on our spare tire well enclosure. It comes in 2mm and 4mm varieties. I recommend the 4mm for enclosures. To saturate and cure our cloth, we'll need polyester resin and MEKP hardener. This is what will give our cloth strength when cured. Resin is sold by the gallon and usually comes with enough hardener to mix the resin at 1%. I recommend purchasing marine-grade resin rather than resin available at hardware stores, which contains a wax. This waxy surface will need to be sanded between cured layers. Expect to pay about $20 a gallon for a good quality layup resin. You may also choose to purchase additional MEKP if you want to mix your resin at a ratio higher than 1%. I also recommend purchasing a squeeze measuring container for the MEKP. Mixing cups and stir sticks will be needed to mix the resin and hardener. I recommend both 1 and 2.5 quart size plastic cups. They are widely available and cost about 50 cents each. They can be reused several times when working in straight fiberglass resin. Body filler and resin mixtures can only be used once. A mold release agent will be needed to keep the resin from sticking to surfaces. I use several release agents depending on the application. For duplicating kick panels, I use Meguiar's Mirror Glaze Mold Release Wax. For spare tire well enclosures, I use plastic drop cloths in conjunction with aluminum foil and regular cooking spray. There is also a sprayable release agent called PVA, which stands for polyvinyl alcohol. It works very well, but the time it takes to set up and clean up is often more than the other methods. It's also a lot messier. A black permanent marker will be used for marking out a mounting surface and for highlighting a cut line on transparent fiberglass pieces. We'll use standard chip brushes for applying our resin. I recommend picking up the 2-inch brushes for most work. They're sold individually and by the case of 24 or 36. I'd recommend picking up a case since they are relatively inexpensive. Latex gloves are an absolute necessity. These protect your hands from the very sticky resin and body filler. Resin is almost impossible to wash off and burns to your skin as it cures. Gloves are sold by the 100 box and are about $7. Acetone is about the only thing that will remove polyester resin and can be a real lifesaver when cleaning up spills and tools. It's about $8 a gallon and is highly recommended. A hydrocarbon rated fume mask is another highly recommended item and is an absolute necessity when working in confined spaces such as the trunk. It filters out the very strong fiberglass resin odors, which can also be dangerous. $20 will get you a good quality mask. A fiberglass roller can be a very useful item for removing the bubbles that often appear between layers of fiberglass. This is especially true of large flat areas. Expect to pay about $5. Body filler is another staple of fiberglass fabrication. Body filler adds a lot of strength to projects and also makes a great material for filling in large gaps. There are several brands available, but the one I use is Rage Gold from Evercoat. It's about $20 to $25 per gallon and is available at auto body repair suppliers. If you don't have a center in your area, you can order it through the mail, or you may be able to talk your local auto body shop into ordering it for you. I also use a fiberglass reinforced body filler called Duraglass. There are also other brands available such as Marglass and Kitty Hair. These fillers are a little more expensive and run about $30 per gallon. They do add more strength because of the fibers, but are also more difficult to work with. To shape the body filler, we use simple plastic spreaders. As it begins to harden, we use a body filler shaper blade to take down the high spots. To sand our fiberglass and harden body filler, we use a variety of sandpapers. The most commonly used grits are 40, 80, 220, and 400. The lower the number, the more coarse the sandpaper is. The smoother the finished enclosure covering, the higher sandpaper you'll eventually need to use. When sanding items, it's important to wear a dust mask to keep from breathing in fiberglass fibers and body filler dust. A simple paper mask is better than nothing, but a better quality mask is recommended. The fume mask can be used, but I'd recommend purchasing different filters for sanding. The higher quality hydrocarbon filters will plug up very quickly if used for sanding. When sanding fiberglass or fiberglass reinforced body filler, it's important to protect your exposed skin. The small fiberglass fibers get everywhere and will cause you to itch like crazy. To help prevent these fibers from attaching to your skin, you can coat it with talc or baby powder. You can also wear a Tyvek suit, which is recommended for extensive sanding. These are about $6 and can be reused several times. Let's begin with a discussion about fiberglassing. Fiberglass work in car audio has been around for many years, but it's only been in the past several years that it's really evolved into a major portion of the custom work done. We see more and better fiberglass work as more installers learn to work with it. This growing expertise has given rise to the more advanced shapes and installations in vehicles ranging from top competition winners to everyday drivers. What was once a skill possessed by a few top installers has now become more and more a necessary skill for all installers. By learning to work with fiberglass, you'll be taking your skills to the next level. One of the first things you learn when working in the fiberglass arena is that you won't always use actual fiberglass. Many times other cloths will be used in conjunction with polyester resin to form the desired shape, and fiberglass cloths will not be used at all. These other cloths include grill cloth, trunk liner, felts, and fleeces. Knowing when to use each type of cloth will save you the time and expense of working with fiberglass. Automotive body filler is another product that you'll use extensively when working on your fiberglass projects. In fact, many of the materials you will use will come from the automotive or marine repair industries. One property of fiberglass that is important to remember is that fiberglass has more strength and curves than on flat panels. This is why we can make enclosures thinner than the 3/4 inch we would need if the enclosure was made from wood. It's also why we use MDF for any major flat areas on our projects. The 3 steps that almost all fiberglass projects have in common are the creation of a base, either wood or fiberglass, the formation of a frame, which will be wrapped in cloth, and the actual wrapping and resin application that will harden the wrapped structure. Look for each of these steps in the 3 projects we'll be demonstrating. Our first project will be a set of custom kick panels. These are one of the most requested items in a custom installation. They allow the front speakers to be placed in a more ideal mounting position compared to a door or dash installation. They also add a custom look to the install, which can be further enhanced with materials such as vinyl and paint. They require very little material to create and can be a good source of profit. They can also be created relatively quickly once you learn how to work with various materials involved. Let's get started. First thing we need to do is create a base for our panels. There are two main options to consider. The first, and the one I prefer, is to use the factory kick panel or a fiberglass copy of it. The other is to build a base around the floor of the vehicle. I prefer the factory kick panel for several reasons. First, it gives an easy fit and the factory look to the custom panels. Second, it doesn't require that the factory floor mats be customized to fit around the kick panels, and also leaves full legroom for the passengers. This is the method I will concentrate the demonstration on, but for completeness I'll first show how to build a fiberglass base without the factory kick panel. First, decide how much of the kick panel area you want to cover with the new pods. Do you want to include the area of the factory kick panels, or do you want to work around them? Once this decision is made, you need to add 2 layers of tape to the area you have chosen. I recommend a good quality 2-inch masking tape. I prefer the 3M brand. Start at the bottom of the area and work your way to the top, overlapping the layers by 1/3 to 1/2 the tape width. Doing so will ensure that any resin on the tape will not run between the overlapped layers. Once the tape is added, you'll also want to add a protected area around the main area with plastic drop cloth or aluminum foil. This is to protect the vehicle interior from accidental drips. Then use a permanent marker and draw out the area of the actual pod. When the fiberglass and resin are applied, the marker will stick to them and give an easy-to-see line that will be used as a guide for trimming. Now that the area is prepared, you can add strips of fiberglass mat and soak it with the fiberglass resin. You'll definitely want to wear your fume mask when working in the kick panel area. Also be sure to open up all of the vehicle's doors so that the fumes can escape. Ensure that all areas of the marked line are covered, and use caution not to drip resin outside of the taped area. When the resin has dried, peel off the fiberglass and remove the tape and foil from the interior. Keep the doors or windows of the vehicle open to allow the rest of the fumes to escape. Now take the fiberglass piece and trim it along the transferred line, and you'll have your base. Double check the fit and you're ready to begin framing and wrapping the piece. These techniques will be demonstrated on the factory kick panel based pods. Here you can see the plastic factory kick panel after it has been removed from the vehicle. We could use this panel, or if the owner wants to keep the factory panels, we can create a duplicate out of fiberglass. First, cut pieces of fiberglass mat for each panel to be duplicated. This should be large enough to cover the panels and to stretch around the curved areas. Use several layers if using a thin mat. Here I am using 2 layers of 1.5 ounce chop mat. I've also cut several small squares that will be used to fill any missing areas. Second, use a mold release wax and coat the factory panel with it. If your factory panel is carpeted or covered in a material other than plastic, then you'll want to tape it up first to protect these surfaces, then wax the tape. You'll need to wear your latex gloves for the rest of the process. You may also want to wear your safety glasses or goggles to prevent splashes from getting into your eyes. Using the plastic mixing cup, resin, and MEKP hardener, mix up enough resin, about 4 ounces per panel, at a 1% hardener to resin ratio. I'm using a graduated mixing cup and an MEKP dispenser to assure accurate mixing. Using a 2-inch chip brush, begin applying the mixture to the mat on top of the factory panel. Soak the mat until you can clearly see the factory panel. Apply to the entire panel, paying special attention to the curved areas. Pull the soaked mat around the curves if necessary. If this causes some areas to lose mat, add the small repair squares cut out earlier. Be sure to push in any factory screw holes so that the factory screws can be used to hold the new panel in place. Add the second layer of mat and repeat the process for the other panel. Push out any air bubbles by poking the mat with the brush tips. This is called stippling. To hold the soaked mat in place on the curved areas, add a strip of aluminum foil to the edge and clamp it using several clothespins. The aluminum foil will keep the clothespins from bonding with the fiberglass resin so that the clamps can be easily removed when dry. When all areas are covered with the mat and the clamps are in place, the piece can be placed on a small pedestal to avoid putting the fiberglass and resin onto a working surface. Here I am simply using a spare 1-quart plastic cup. Place your brush into a container of acetone to clean the brush and keep the resin from drying to the bristles. The brush can then be reused. While the panels are drying, we can create the mounting rings for our speakers. We'll be creating 2 rings, one for mounting the speaker, and the second ring will be used on top of the first. The second ring will be used to flush mount the speaker into the new pod. We'll create both of these rings with a plunge router and a circle jig. Here you can see the circle jig mounted to the base of the plunge router. A 1/4-inch straight cutting bit is used to cut out the rings. Keep in mind that this circle jig and its markings are calibrated for cutting holes, and so the outside diameter of the cut is what is marked out. If you want to cut out a 6-inch ring or disc, you'll need to set the circle jig cut out 6 1/4-inch hole. Here we're using an MDF top work surface and drill an 1/8-inch hole in to accommodate the 1/8-inch pin being used as a point of rotation. Next, take 2 pieces of wood large enough to create the rings and drill 1/8-inch holes in them. This will be the center of the ring. I'm using scraps of wood cut from larger woofer openings. We want our flush mount ring opening to be large enough for the woofer grill, plus the material we'll use to wrap the pod. We'll also want it to be about 1/2 inch in width. Since our grill is 6 inches wide, we'll make the inner opening 6 1/8 inch, and the outer diameter will then be 7 1/8 inch. The bottom mounting ring will be 7 1/8 inch in diameter to match the flush ring, and the inner opening will be our speaker mounting hole diameter. You'll definitely want to wear your safety glasses and probably hearing protection for this process. Begin by cutting out the 7 1/8 inch outside diameter for both rings. Set the pin into the circle jig at the 7 3/8 inch mark, and then place the pin through the ring material and into the hole in the MDF top of the work surface. Set the depth on the plunge router to a little more than half the material thickness. Turn the router on, plunge and lock the bit in place, and rotate the router around the center pin. When the entire diameter has been cut, turn off the router and return the plunge to its unlocked position. Flip the ring material over and repeat the process for the other side. After the outer diameters of both rings have been cut, move to the inner diameters. Set the flush trim ring inner diameter to 1 inch less than the outer diameter and repeat the cut process. Set the mounting ring inner diameter to the speaker mounting hole diameter and repeat the cut process. We'll also make a third piece at this time that has an outer diameter slightly less than the inner diameter of the flush trim ring. We'll be mounting a common laser pointer inside this piece to help us get proper imaging for the baffles. To make the piece sit flush in the baffle, we'll wrap it in tape until it fits snugly. Now remove the piece and drill 3 holes in the baffle, one in the center large enough to mount the laser pointer. The other 2 holes will be used to pull the piece out of the baffle. It's very important that the middle hole is centered and drilled at a 90-degree angle to the baffle. Use a drill press or your plunge router to make this hole. Finally, insert the laser pointer in the middle of the hole. Again, wrap it in tape to get a snug fit. With this piece in place, we'll be able to tell exactly where our kick panel pod is aiming. After all rings have been made, you will want to soften the hard edge of flush trim rings by using a roundover bit. Here we've set up a small router table with a 3/8 inch roundover bit. Adjust the bit so that its bottom blade is flush with the table. Then turn it on and add the rounded edge to one side of the flush trim ring. Now drill the holes for the speaker to mount to on the mounting ring. Finally attach the 2 rings together. I'm using CA glue for these rings. Next, cut out 6 strips of 1 inch wide MDF. These will be used to prop up the mounting rings on the fiberglass base we are creating. Make each stilt about 6 inches long. These will later be trimmed down. We'll use 3 stilts for each panel. By the time these tasks are completed, the fiberglass should be cured. You can tell when the curing is complete because the piece will no longer give off heat. Test the stickiness of the fiberglass with your glove to see if it is safe to handle. If it is, then you can remove the clothespin clamps and aluminum foil from the piece. Take a black permanent marker and trace out the border of the factory panel. Remove the fiberglass mold from the panel. If any resin leaked onto the plastic panel, it can be wiped off with acetone and a rag. You can also remove the excess resin from the plastic cup so the cup can be reused. Press along the edges of the cup to break the resin free from it. Once the resin is free, you can slam it upside down onto your work surface and it should pop right out. Remove any stray pieces of resin from the cup and it's ready to reuse. Now cut out the fiberglass piece along the marked line. Be sure and coat your exposed skin with talc to prevent fiberglass strands from sticking to it. Here I'm using an air body saw to cut out the piece. You could also use a Dremel or rotozip type tool with a spiral cutting bit. When the cutting is complete, you'll have a near perfect copy of the factory panel to use as your project base. Now we have our base, rings, and 1 inch mounting stilts. Our next step is to add the stilts to the base and ring combination. But to do this, we'll need to make sure we mount the rings with enough depth for the speaker and at the proper angle for good imaging. Place the fiberglass panel copy in place of the factory panel in the vehicle. Place the laser pointer piece into the baffle and take the combination to the vehicle along with the mounting stilts and a black permanent marker. Now aim the baffle so that it is pointing at the vehicle's dome light. You may want to have a partner help you with this. Then take one of the stilts and place its outer surface against the ring and mark the line and the angle you'll need to add to the end. Repeat for the other 2 stilts. Remove the panel, rings, and stilts and move them back to the work area. Cut the stilts to the proper length and angle using the marked line as a guide. Then attach them to the base and rings using hot glue. CA glue forms a better bond, but hot glue fills in small gaps better. Once the pods are completed, the stilts will not add any significant strength to the structure, so either glue will work. When the stilts are in place and the glue is dried, it is time to double check the mounting angles. Take the structure back to the vehicle and make sure that the angles are correct. If they're not, then break loose and adjust the stilts as necessary. This can take many tries to get it right, so try not to get frustrated. When everything is okay, then we're ready to begin wrapping. To To wrap our basin frame, we'll need to use a non-fiberglass cloth. We can't use fiberglass mat or cloth because it will sag and fall apart when the resin is applied to it. So first we wrap with any number of cloths. The thinner and stretchier the material, the better it will conform to curves. Common cloths from thinnest to thickest are grill cloth, trunk liner, fleece, and felt. Kick panels are a good place to use the thinner materials. Here I'm using a polyester fabric called PK knit. It's similar to grill cloth and is semi-stretchable, but at half the cost. It's available at most fabric stores. Now cover the speaker hole opening with masking tape. This will prevent excess resin, trimmings, and dust from getting inside the pod. Then begin the stretching process by spraying the backside edge of the fiberglass panel with spray adhesive. Flip the piece over and drape the cut cloth over it. Then begin the process of pulling and pressing the fabric to the sticky edge on the back side. The idea is to create a form-fitting exterior with no wrinkles or sags that we can apply a layer of resin to. When the wrapping is complete, it's time to apply the resin. Mix up another batch of 1% resin as before and apply it with a paintbrush to the stretched fabric. Do not apply resin to the backside of the cloth or the spray glue will release and you'll have to re-wrap the piece. Only brush resin up to the edge of the panel. Cover the entire front of the piece with resin, including the area in the middle of the ring. This will need to be stiff so that it can be easily cut out later. Place the piece back on the stand and place the brush back in the acetone. Let the resin cure. The resin is cured when the exterior is stiff and no longer sticky. When this happens, you're ready to begin strengthening the enclosure. We could add fiberglass mat at this point, but it's not necessary since we'll be using body filler to fill in the gaps and smooth out the pod. Body filler will give us the extra strength we need. You'll want to wear latex gloves for this as well. First, give the resin a quick sand with a rough grit sandpaper. Nothing extensive, just enough to remove the shine and give the body filler a better surface to adhere to. Then begin scooping out and mixing the body filler with hardener on a piece of scrap MDF. I use a plastic spreader to mix and apply the filler. Rage Gold is yellow when used as a blue-cream hardener. When they are properly mixed, the result will be a pale green. Be sure to mix thoroughly since any unmixed body filler will not cure and leave soft spots. Once the body filler is mixed, it will begin to harden, so you'll need to work quickly. Use the plastic spreader to apply and roughly shape the body filler to the pod. Look for major gaps and areas that need extra attention as you rotate and apply filler to the piece. When you're satisfied with the coverage, you can place the piece back on the pedestal. Now keep a close eye on the body filler to see when it begins to stiffen up. This is when you will be able to take down the high spots in the filler using your shaper blade. If you wait too long, the body filler will be very difficult to work with. If you shape it too soon, the form will lose shape and the blade will clog up with filler. Test the high spots with your gloved finger to see if it is stiff enough to work. Again, you'll need to work quickly, so don't spend too much time in one particular area. Run the blade over the top of the high spots and the filler will come through the blade like cheese through a cheese grater. When the rough shaping is complete, you can put it back on the plastic cup and wait for it to cure. Because of the short curing time of the body filler, I would recommend only mixing enough filler to do one panel at a time. While the first panel is curing, you can begin the work on the second panel. Once the curing is complete, you can further shape the filler by sanding. Use a rough grit of 80 or below to further remove the high spots and give the panel more shape. You can do this by hand or use a power sander, either electric or air. I prefer to use an angled die grinder with a small sanding disc. For first-timers, I would recommend you do at least some of the sanding by hand. This will give you a better feel of how the piece reacts to the sandpaper and how much pressure and time you'll need to spend on each area. This is invaluable experience. You'll notice here that we've sanded through the body filler in some places and have small gaps in other areas. We'll remedy this by adding more body filler, but instead of spreading it on, we can mix it with fiberglass resin and either brush or pour it on. For these kick panels, I'll demonstrate how to make a mixture that can be poured on. This is something you'll want to wear gloves for. Begin by taking a plastic mixing cup and filling it with body filler. About 4 to 6 ounces should do for each panel. Then add an equal amount of fiberglass resin to the mixture and stir it thoroughly. When the mixture is properly mixed, add enough MEKP hardener for a 1% ratio, as if the entire mixture were pure resin. So if you mixed up 8 ounces of mixture, then you'll need to add 2.5 cc's of MEKP. You do not need to add the cream hardener, though I have done it both ways and find little difference. You'll want to experiment for yourself. Start the pouring on the far curved side. Cover that side well and then place the kick panel pod onto the plastic cup pedestal. Then starting from the inside of the flush trim ring, pour the mixture evenly over the entire surface so that the mixture runs off the pod, making sure that all areas are covered by the pour. This pour will fill in the small gaps and low areas while giving us a surface that is much smoother than we would normally get with straight body filler. Once this is cured, we can begin the final sanding process and smooth the pod as much as necessary for our final covering material. The smoother the final surface, the more we'll need to sand it. Carpeted pods will work well with only an 80 grit sanding. Vinyl cover surfaces should be smoothed to a 220 finish. Painted surfaces will need to be nearly flawless with a 400 grit or higher finish. I would recommend that you do not try to paint your first kick panels until you have more experience. Any imperfections will show up in the paint and ruin the final look of the piece. Once sanding is complete, it's time for a final trim. Flip the piece over and cut away the excess cloth with a razor knife. Then cut out the speaker ring so that the speaker can be mounted. Here I'm using an air-powered die grinder with a flush trim bit to do the job. A Dremel or Rotozip type tool with a spiral cutting bit will also work. Begin by drilling a pilot hole in the top surface and then run the cutting tool along the inside edge of the piece to trim the piece flush. Here I've completed a second pod without first taping the speaker hole opening to show what kind of junk can get inside the pod. Notice the small shavings that have lodged inside the pod. Over time these will come loose and could possibly damage the voice coil of the speaker. This is why we spend a few seconds taping off the speaker opening. Now we do a final check of the fit in the vehicle. Everything looks good, so we'll call it a success. Now we're ready to turn a regular subwoofer enclosure into something more eye-catching. Here we've created 5 sides of a 6-sided enclosure out of MDF. So far it's the beginning of a basic enclosure, but with a little fiberglass work we can turn it into something worth looking at as well as listening to. We begin the process in a similar manner to the kick panel pod. First we start with a base. This is our MDF enclosure. Then we add a frame for cloth to be stretched over. We create a set of mounting and flush trim rings exactly as we did for the kick panel pods. We mount them above the enclosure using the 3 stilts as before. We could angle the mounting ring out or in, but we'll leave it flat for this enclosure. If you're building an enclosure with multiple woofers, you'll probably want to angle the woofer either towards or away from each other for a more stylistic approach. Once the rings are mounted to the stilts, we can begin the wrapping process. We'll be using fleece, specifically polar fleece, for our wrapping cloth. It is both more stretchable and holds more resin as compared to the thinner grill or knit cloth. Notice that the cloth is much stretchier in one direction. We want the stretchy direction to be oriented in the direction we'll be pulling the cloth. Begin by spraying a ring of adhesive around the perimeter of the enclosure. Then attach the cloth to one side and pull it and attach it to the opposite side. This should be using the non-stretchy direction of the cloth. Now pull the cloth to the 2 remaining sides so that the cloth is tight and all wrinkles are removed. This should be done using the stretchy direction of the cloth. In order to form a strong bond with the enclosure, we need to staple the cloth to the top of the enclosure. Use 1/2 inch long staples and place them along the enclosure perimeter 1/2 inch apart. This is the correct way to do it. However, I'm going to demonstrate why you need to staple the cloth down by creating the enclosure without staples. I'll also show you how you can still salvage the piece if you forget or are unable to use the staples. Once the cloth is in place, you can mix up and apply resin to the fleece. You'll need to use much more resin for the fleece as compared to the knit cloth. This is because of the much greater thickness of the cloth and its ability to soak up resin more effectively. Again, do not brush resin onto the glued area of the cloth. Only brush it up to the edge or the glue will release. When the resin has cured, the piece will be very stiff because of all the resin used. For large high-powered enclosures, you may want to add layers of fiberglass mat, but usually you only need to use the fleece. It doesn't hurt to add the extra layers, but it does take extra time and money to complete the project. Instead, you can use a fiberglass reinforced body filler. Here I'm mixing up some Duraglass to apply to the enclosure. It's similar to regular body filler, but is a little stiffer and harder to work with. As before, add the hardener and mix it thoroughly. Then apply it with a plastic spreader and wait for it to cure enough that it can be shaped with the body filler blade. After the piece has cured, you can begin the sanding process as before. When sanding fiberglass reinforced body fillers, you'll need to protect your exposed skin with talc. As you sand the filler, the fiberglass strands will come loose and attach themselves to your unprotected skin. Once the enclosure is rough sanded, it is ready for a second coat of regular body filler. We will not be able to pour the mixture on as before because the excess will run all over our enclosure and cause a mess. Instead, we'll want to create a mixture that can be applied with a brush. Instead of a 50-50 mixture, I usually do a 1/3 resin to 2/3 body filler ratio. What you're shooting for is a mixture that is thin enough to paint without being so thin that it runs off the enclosure. You also want it thin enough that the brush strokes will disappear as you apply it. Mix up the resin and body filler mixture in the cup, and then add the MEKP hardener like we did for the kick panel pods. Once combined, begin painting the mixture to the top of the enclosure and work your way down in sections, eventually coming back to the starting point. Notice that the extra cloth acts as a drop cloth for some of our small drips. Once the mixture is cured, we can pry the top from the enclosure. Here we can see why the top came off so easily. There is very little bond between the fleece and the MDF enclosure. This is why we need to add staples to increase the surface area of the bond and add a mechanical fastener to the piece. but we can still salvage this piece. First we'll need to trim the top using a body saw or electric cutter with a spiral cutting bit. Next we mix up some regular body filler and apply it to the top surface of the MDF enclosure. Once all edges have a generous portion of body filler, we can set the form top into it. This will bond the two pieces together. If there are any gaps between the two pieces, we can apply body filler to the gaps. This can then be sanded flush for a perfect fit. Finally, we cut out our speaker hole using a flush trim or spiral cutting bit and sand the enclosure as needed. Here you can see how different levels of sanding will give different degrees of surface perfection. We have an unsanded section, a section sanded with 80 grit, one sanded with 220 grit, and one sanded with 400 grit. Each is a little smoother than the last, with 400 grit being ready for paint. Our final project will be the construction of a spare tire well enclosure. This is a very popular installation technique when trunk space needs to be maximized, or the owner wants an ultra-stealth installation. Here the subwoofer will use the space normally occupied by the spare tire. The biggest drawback to this method is that the spare tire needs to be removed and won't be available in an emergency. Make sure the owner is aware of this before proceeding. The first step in this installation is the removal of the trunk carpet, wheel well baffle, and spare tire. Some spare tire wells will have large threaded bolts sticking up from the bottom that will probably need to be removed before beginning the installation. This vehicle has a small bump that a threaded bolt screws into. We could remove this, but it's so small that we can work around it. Just make sure that there is enough depth to mount the subwoofer if a flush installation is desired. After the extra items have been removed and the wheel well has been vacuumed out, it's time to start laying down our protective surface. This is to prevent excess resin from getting on the trunk surfaces and to keep the fiberglass resin from sticking to the spare tire well. I'm laying down a large drop cloth as our secondary level of protection. Our primary level of protection will be a layer of aluminum foil that is form-fit into the well. Be sure to tape the seams between sheets to prevent resin leak-through. When all taping is complete, we add our mold release. A simple kitchen cooking spray works very well and is easy to apply. Now we can prepare our fiberglass mat. I'm using a 3-ounce chop mat that comes in a 4-inch wide roll. Cut several lengths that will cover the width of the well. Cut one set for each layer you plan to add and also cut some square patches. Once the mat is ready, we can mix up the resin. This is definitely a job you'll need to wear a fume mask for, since the vapors will be concentrated in a very small area. Be sure and open the doors or windows of the vehicle to let the resin fumes escape the interior. Now put on gloves and mix up 1 liter of resin at a 1% resin to hardener ratio. Once thoroughly mixed, begin saturating the chop mat 1 layer at a time. Saturate the mat until it becomes transparent. Be sure and saturate the mat at least 2 inches past the top edge of the spare tire well. We'll need this lip to mount our baffle board to. When the first layer is complete, you can add a second layer of mat directly over the first layer. I wouldn't recommend adding more than 3 layers of mat at one time. Now let the fiberglass cure in the well with the trunk lid open. For the final layers, we'll be working outside of the vehicle. It's easier and eliminates the chance of spilling resin on the vehicle or in the trunk. It also lets the owner take the vehicle home for the night if they need it. Remove the tape where it attaches to the vehicle and simply pull the fiberglass tub out of the well. It should come out easily because of the plastic and foil layers. Now invert the tub onto your work surface and remove the plastic and foil. The cooking spray will allow the foil to peel off easily for the most part. You may get a few places that stick, but that's okay. They should come off with a little prying. Now we're ready to add our final layers. We could keep adding fiberglass mat and resin, but this is more expensive and time consuming. Instead we'll add a layer of core mat followed by another layer of fiberglass mat to keep it in place. Core mat is a chopped fiber polyester fabric that is used to thicken and strengthen the enclosure. It will save time, weight, and fiberglass when creating our enclosure. It also doesn't warp like an equivalent amount of curing fiberglass would, and the 4mm version is the equivalent of about 4 layers of fiberglass mat. Because core mat is so thick, we will need to pre-cut it to the curves of our enclosure. Keep the enclosure inverted and wipe off the cooking spray residue with a damp soapy rag. Dry it with a towel and add a light coat of spray adhesive to the top to make the surface semi-tacky. Now take a piece of core mat large enough to cover the enclosure and take into account the curved areas and place it on the inverted enclosure. Cut in from one edge until you reach the edge of the enclosure bottom. Move over about 6 inches and repeat the process. When all cuts are complete, you can flip the enclosure over and add another coat of spray adhesive. This one should be heavy enough to make the core mat stick to the enclosure. Then press the core mat to the bottom. Finally overlap the seams of the cuts and make a flush cut from the top to the bottom. Remove the 2 pieces of core mat that were cut out and press the seam in place. Repeat this for all other overlaps. Now pre-cut strips of fiberglass to lay over the top of the core mat. This is the same process we used for the first layers of fiberglass. When everything is laid and ready, you can put on your gloves and fume mask and mix up the needed resin. Core mat soaks up a lot of resin because of the thickness, so plan on using at least a half a gallon of resin for this step. You can mix the resin in 2 consecutive batches instead of all at once. This will increase your working time before curing. Begin by pouring a generous amount of the resin over the bottom of the enclosure and spread it around the enclosure. Use your brush to push the resin into the mat and to eliminate air bubbles using the stippling technique. I'm adding 2 layers on top of the core mat for extra strength. Once both layers are complete, use your fiberglass roller to remove any remaining air bubbles. Place your brush and roller in acetone and let the resin cure. Set the enclosure in the sun if possible to speed the curing time. After the enclosure has cured, cut the excess material away from the enclosure lip. The remaining piece will be what we mount our MDF baffle to. Place the trim piece in the spare tire well and double check for fit. Now place the inverted enclosure onto a piece of MDF large enough to cover the opening. Trace along the edge with a permanent marker. With the size of this enclosure's lip, it is necessary to trim another inch from this line. We'll also use a routing bit to help the MDF baffle seat properly on the enclosure lip. Here you can see the gaps that exist between the enclosure form and the flat MDF baffle. We'll cover these with more fiberglass later in the process. Also note the alignment marks that were made to match the enclosure to the baffle. A total of 3 marks were made for matching. If we were using an MDF ring and wrapping in fleece, we would not need to bridge the gap with fiberglass or make an MDF baffle to fit. However, if we want a strong flat surface, we will need to make a baffle from MDF. Before attaching the baffle to the enclosure, we'll cut out the subwoofer and terminal cut mounting holes and pre-drill the screw holes. For the speaker hole, we'll be using our router and circle jig again. The speaker hole will also be routed to flush mount the subwoofer. The terminal cup will be cut out with a plunge router. Adding a thin layer of sawdust to the surface will help the router glide more easily. To attach the MDF baffle to the fiberglass tub, we'll use construction adhesive. Since the 2 pieces do not meet in all places, we'll mark out on the baffle where they do meet. This is where we'll add a generous line of adhesive. The rabbited edge gives us more surface area for bonding. Be sure to wear gloves, as construction adhesive is not something you want on your skin. After the baffle is in place, add another line of adhesive to the outer edge. You are now ready for the fiberglass. Pre-cut 12 to 18 inch strips of fiberglass mat, mix up about a half a liter of resin. Begin by painting a layer of resin to the MDF baffle edge and then place a strip of mat over it. Soak the mat with resin to bond it to the baffle and the fiberglass lip. Push out any air pockets with the brush. Make sure that the mat is attached securely to the baffle and the lip. Add a second layer of mat directly on top of the first layer. Once both layers are in place, move to the next section of the enclosure. When the entire enclosure edge is covered with 2 layers of mat, add a third layer of mat on top of this. Because this edge is curved, it will be very strong, and 3 layers is all we will need. After the resin has cured, we can go back and cut off the excess fiberglass along the lip edge. There will still be small holes along this edge, so for extra assurance we will mix up some more resin and apply it to the enclosure edge. Be sure to push the resin into the edge to make sure any small holes are filled. After the final resin application is cured, we can mount our hardware and check the final product. The enclosure fits perfectly into the spare tire well and disappears once the factory carpet is in place. Don't forget to add a grill to the subwoofer to protect the cone from objects placed in the trunk. That concludes this video. I wish you success with your own fiberglass projects. Have fun and good luck.